Gentles and ladymen, I'm Spiro, and I'm not a wizard. Today we're going to do part 2 of our ICEBERG type-in program from the Usborne gaming book. If you haven't seen part 1, that is probably a good prerequisite. I'll leave a link to it in the description below. Go check that out. That's where we did the initial type-in of the program, and we got it to a point where it is running as per the book. In this episode, we're going to extend it. Now, with the exception of some color changes, I'll run the game here. Let's do a listing. And this is, why is that a syntax error? Am I retarded? There we go. So this is effectively what the original game is like. The exception being I've changed the colors, background, and as you can see here, the colors of the characters on the screen. Other than that, this version is as per the book. So what happens is we've got this is our board. The cyan asterisks are icebergs, the yellow Y is U, and the red Z, or Z as you might pronounce it in some other countries, is the enemy ship. So you've got to avoid the enemy ship. Really the only way to win this game is to get the enemy ship to crash into an iceberg. So the AI has it so that the enemy follows you, but it has the story in the book is it can detect you as the other ship, but it can't detect the icebergs. So you have to trick it into hitting an iceberg. And the original game was you have the directions north, south, east and west. Oh, okay, there we go. I did make one other change, which is instead of using input, you now just hit the key of the direction you want to move in. But as you can see, each time it is redrawing the entire screen. He's moving closer to us, and I just keep moving south. So he's still coming. So as you can see, it's a nice start, but not what we want. So let's break out of that. What I've done is to make it a little bit easier to work on. I converted the code from the C64 to plain text. There are other videos on the channel that show how to do those conversions back and forth. Go check those out if you need that, or just download the code from my GitHub repository. Again, links down in the description. So because we're what I've got is I've made the changes here, and I've got them so that they're not indented, so you can see what I've done. The first thing I did was I played around with the colors again. The grey with the light colors, light foreground colors, just wasn't really working for me. So I've changed it to a black background, so those two pokes will change it to the background and the border to 0. Now the random number generation was predictable. Each time you ran it, the first time you ran the game, the all of the icebergs were in exactly the same position. So what I've done is I've seeded the random number generator to use the clock timer. So that's what that TI variable is. This, in basic terms, because that's all that I understand, is that the TI will seed the random number generator based on jiffies since the computer was started. So there are 60 jiffies in a second, and I'm not sure why initializing that at the beginning works, but from then on we just go random 1, and that seems to generate more random stuff. If you want to know how the random number generation stuff works, check out the channel 8-bit show and tell. Robin did a video a while back of explaining how all that works. So all I'm going to say is we seed the random number generator and we're going to get more random results. So in this version of the code, we've got at line 150 there's a print clear screen. That's basically where the loop of the game starts, and we've got here on line 420 go to 150. So this line 150 through to 420 is effectively the main game loop. After that is where it gets printed out, the various in-game effects. So what we wanted to do was we didn't want the screen to be cleared each time the game loops around. So I've moved the clear and the title of the game onto its own earlier up in the initialization of the game. So it'll clear the screen, print the title of the game, generate the random numbers. So the SX and SY are the X and Y locations of the enemy ship. The N is the number of icebergs that are generated, and if you check out the last video, the G indicates the size of the grid. So the initial game out of the book was an 8x8 grid, and we kind of extended it to a 16x16 grid. So that is my faulty pipes and my dishwasher causing my faulty pipes to whine. If you could hear that. It's a great sound. The cats love it. YX and YY is your X and Y location, so the player ship. So these are all randomly generated at the start of the game. So here we get into a loop. We will go this here. Oops, I should say this from YX. This bit here is what I'm not sure if you can see that. I'll make that a little bit bigger. Hopefully that's clearer for you there. Sorry about that. This bit here prints the grid. So it's generated what's going to be on the grid. Anything that hasn't been, so if it's not if it's not an iceberg, if it's not the player ship and it's not the enemy ship, then it's going to be a dot, and that is indicated here. So if the B, which clever viewer Jeremy Nasmith pointed out, I thought it stood for background or something. I didn't know what it was. He said it probably stands for board, because we're playing on a game board. Smart guy. So if the board location or coordinate is if it's a 0, so if there's nothing there, then it's just going to print a dot. So I've got that printing in blue. I've got the character 42 is the asterisk, so that is the icebergs, that's printing in cyan. Character 89 is the letter Y, so that's been printed in yellow, and 90 is the letter Z, and that has been printed in light red. So it's just going through and it's printing the grid initially. Once that's done, it'll print the thing that says what you got to press to move around. Now I've actually added arrow keys as well, but I haven't changed that prompt. And we've changed the input command, which in the book, and also did that here, to get. The input command makes it so that you've got to press a direction and then press enter, right? And plus it's got that ugly question mark at it. So this here, by just reading a character raw, means that we can kind of move around a lot like a like a roguelike or something. You're just kind of moving your character around the screen freely, and it's much nicer. Once we get a key, so once you've tried to move in a direction, it will then, I've set some dummy variables starting with Z. So ZC is the ZC string is the character, or the string that's going to be displayed for the background. So the dot. So what this is doing is it's saying it's basically going to presume that you're going to move. So it's going to clear the space that you are currently on by replacing it with a full stop. There you go, those pipes again. The other way to do it is if we had that's stuffed. Oh, that doesn't sound good at all. That sounds naff. That's all right. The neighbour, aka plumber, is coming tomorrow. We're going to presume that we're going to move, and so we will replace that. Wow, that's worse than I've ever heard it before. And what we're going to do is say that the other way of doing it is to maintain two sets of variables. One is for your current location and one for your previous location. This is kind of a way around that. So we just say, assume they're going to move somewhere, and just replace the character at the location they're at with a dot, and replace the character in the board grid with a 0. And the reason for that is because the collision checking checks for the character at that location. So when the enemy ship moves into a new grid location, it doesn't say, is this a match for the player location? It literally checks to see what text character is in that grid location. So if the enemy ship moves into the player location, it checks for the character 89 or a Y. If it moves into a location and it finds a 42 or an asterisk, it knows I've hit an iceberg. Otherwise, it will say, okay, well, it can move around freely. So that board grid location is, we're changing it to a 0 to say, okay, we're moving, so the space we were in, there's now nothing there. and I set a couple more temporary variables for X and Y, and then I do a go sub, because this is a routine I use several times. So 450, we jump down to here, so that's this routine here. So what it then does is it moves the cursor to the home location, so the top left, and then it does a quick loop to say for y equals 1 to zy, and zy is where is the y coordinate of where the player is about to move to, or is it about to move to? We're doing it where it's about to move to, so it's its current location. What have I done? Have I done this in the wrong order maybe? We'll get to that. It plays okay. Anyway, so we are... I wonder if I should have done these after that. Anyway, we jump to 450. 450 says move to... oh no, because we're printing the dot now. Need more caffeine. We're printing the dot now, so now we've got to put the dot somewhere on the screen, so it's going to be where we currently are. So it is going to go to home, it is going to go print down a number of lines. So if you're on Y axis 4, it'll go down 4 lines. It'll print that, and then it'll print tab ZX times 2 minus 2. Now we've had to do that because of the spaces in between on the x-axis. So it'll basically jump over to the right location and then print the ZC string, which is in this case the color code and the dot. I took that out because that happens further down here, and then it does the same thing. It puts the same character where the enemy ship was, because it presumes that it's going to move as well. Okay, so now it will update the player X and Y location depending on what direction they moved. So it'll check for if you've pressed north, south, east or west, or if you've used the arrow keys. But it also, as we saw in the last video, it will check that you haven't gone out of bounds. So this is basically the same, except I've added the arrow keys as well. Alright, so then it goes through, it does the collision detection routines here. If nothing has collided, it will go ahead and display 430 is displaying the player, and 440 is displaying the enemy. So it does the exact same thing, sets the ZC string, yellow Y for the player, light red Z for the enemy, and then it will go and print them at their new locations. And that's kind of it. The other changes really were just adding a bit more around the end conditions. So so it'll print it in a different location. Because we're moving around the screen now, the cursor isn't going to be, under the grid. So we've got to account for that by moving the Y down past the grid +3 to account for the line at the top, which has got the game header, and it'll actually print it under the the direction prompt. So it'll go under that as well. But what it'll also do is I'll do another just to indicate how the game ended. I've done another quick screen update which turns reverse on and goes red depending on if you get caught. It will highlight that the enemy ship in red and its location. If you hit an iceberg, it will highlight the location of the iceberg that you hit, and if the enemy hits an iceberg, it will highlight the location that the enemy hit the iceberg. And then it just goes down and it says, would you like to play again? Yes or no. If yes, run. Now the reason I did run instead of go to is because of the way the screen codes are cleared, and I might have actually resolved it later by doing this, but I found that it was leaving a trail of characters on the grid that were from the previous game. So by rerunning, when you run a program in BASIC, it wipes all of the variables and it starts again from scratch. So that's just a little bit of a cleaner way of doing it. So that's our updates. Let's go and see how it runs. Move that over there. All right. So hopefully it looks a little nicer. It's still really slow to draw initially, but the rest of the game is pretty good. So now we're here. He's here. He can move diagonally. We can't. So we can now move around. We can exploit that. We know how the AI works by moving up and down. He hit the iceberg, so it says we're safe. He's hit one. Do you want to play again? Yep. Again. Load. Wait. It'll be really cool to I haven't managed to find a way to speed up that initial drawing. I haven't tried doing pokes directly to the screen or anything, but I imagine those would probably be even slower because we're going through two sets of for loops, one for the y-axis, one for the x-axis, and then each step printing out the characters going, yep, is it this, is it that, is it this, is it that, and depending on what is in the array, it'll print the appropriate characters. But this here, we can actually see now how he's going to catch me because there's no way for me to avoid him. We've been caught. But you can see now how this is actually giving us the foundation for a little roguelike. Okay, we've got our movement, we've got the different things being displayed on the screen. We have got our collision detection routines, we've got our enemy AI who's following us around, and if we turned the board from the sea with icebergs on to a dungeon with walls in it, all right, we've got the fundamentals for that kind of game right here in text mode in BASIC. Okay, the initial drawing is slow, but you know, you can see that the basics of the game would actually work pretty well. Oops. Do I want to play again? Oh, I forgot to press Y. So I think I'm going to have a bit of a play with that and see what we can come up with. It's the only one thing that I'd say that would be a bit tougher in a roguelike or a dungeon crawler that we don't have in this is how to generate effectively a map automatically. So the map screens might have to be predetermined or pre-generated or pre-mapped out. Otherwise, you could end up with corridors being created that lead nowhere. You know, it would be kind of interesting to give it a crack. If you know of any type-in programs that do have a maze type system that gets auto-generated, I'd love to see it. Please leave comments about it down below. But as you can see, it's a super simple game, but gives you so many of the fundamentals of programming a more advanced game that I think that this is fantastic. So I'm going to leave it at that. Grab a copy of the code, which will have the plain text version and the runnable PRG file if you just want to play the game and not really fussed about retyping it, or if you want to have a go at making some changes to the game. And I invite you, if you do like, and this is one thing I wanted to do with my basic tutorial series, was to get to a point after or after a certain point in the tutorial series have a sort of a bit of a challenge or a little competition, not really a competition but more of a challenge, getting you out there to create something based on what you've learned. But I don't see why that we can't do that with this as well, right? This is what can you create with this, or what can you change for this, even if you don't make a whole new game out of it, just modifying Iceberg. Can you make the initial screen update happen faster? Can you change? You can obviously change the characters with existing characters, but what about if you wanted to create your own little custom graphics? So create your own custom characters to display on the screen. That would be cool too. So as I say, I invite you to submit both comments below, and if you make changes to it, if you've got your own GitHub or GitLab or something account, post your version on there and let me know in the comments that you've done it. If you don't, you can email me. If you go into the About page of this channel and you're not a bot, you'll be able to get my email address. And yeah, it'll be cool just to see what else other people can create or can use this to be inspired to create anything, or to just have a play. And that's the aim of these videos, right? It's just to have fun. That's all we're doing. So I'll leave it at that. Thanks for watching. Thanks for your support. As always, leave your comments and thoughts down below, and I'll see you in the next video.